So let's get started with this session with our first keynote speaker of today, which is Jim Kurose. The title of his talk was that I hope you all saw over the YouTube channel for MedComNet, is From Circuits to Packets to Flow to Content to System, how abstractions define a research agenda. And before opening the floor, let me read Jim's bio. I'm sure that everybody knows Jim for many reasons, but mostly because he's the man who wrote the book. There are many interesting things that maybe not everybody knows in his bio. So I'll read it. So Jim Kurose is a distinguished university professor in the College of Information and Computer Sciences at the University of Massachusetts Amherst, where he has been on the faculty since receiving his PhD in computer science from Columbia University. He received a BA in physics from Wesleyan University. He has held a number of visiting scientist positions in the US and abroad, including IBM Research, INRIA, and the University of Paris in France. From 2015 to 2019, Kurose served as assistant director at the US National Science Foundation, where he led the Directorate of Computer and Information Science and Engineering, with an annual budget of nearly $1 billion. CISA's mission is to uphold the nation's leadership in scientific discovery and engineering innovation through its support of fundamental research in computer and information science and engineering and transformative advances in cyber infrastructure. Recently, Jim also served as the Assistant Director for Artificial Intelligence in the US White House Office of Science and Technology Policy. Professor Kurose has served as Editor-in-Chief of the IEEE Transactional Communication and was the founding Editor-in-Chief of the IEEE ACM Transactional Networking. He has been active in the program committees for IEEE Infocom, ACM SIGCOM, ACM SIGMetrics, and the ACM Internet Measurement Conferences for a number of years, and has served as technical program co-chair for these conferences. He is the recipient of several conferences Best Paper Awards, the IEEE Infocom Achievement Award, the ACM SIGCOM Award, and the ACM SIGCOM Test of Time Award. He has also received the IEEE Taylor Booth Education Medal and Teaching Awards from the National Technological University, the UMass College of Natural Sciences and Mathematics, and the Northeast Association of Graduate Schools. He is a fellow of the IEEE and the ACM. Professor Kurose was one of the founders of the Commonwealth Information Technology Initiative and helped lead in founding the Massachusetts Green High Performance Computing Center. He served for 7 years on the board of directors of the Computing Research Association and on the advisory council of the NSF Computer and Information Science and Engineering Director. He served on scientific advisory boards of IMDEA Networks in Madrid and the Laboratory for Information Network and Communication Sciences in Paris. With K3-Discussion, he is the co-author of the textbook Computer Networking, a Top-Down Approach, published by Pearson. And what Jim doesn't mention here, but I think is the most relevant aspect of his bio, is that we've been friends since when we started doing research. We first met, I don't know, 40 years ago, something like this, when we were young, fresh out of school, and we had parallel careers for almost 40 years now. Of course, his career is much more prominent than mine, but we've been friends for a long, long time. So it's a real pleasure, Jim, to have you. Thank you very much. When I asked you, I knew you couldn't tell me no, but nevertheless, I really appreciate you being with us. Thank you very much.
Oh, it's really nice just to be able to. I was really looking forward to being in Arona with people, and so I was simply saying that I was really looking forward to being there, all of us together around the side of the list and having wonderful discussions. First time I've ever put a presentation together like this. I hope it went well. I'm looking forward to the discussion. Thank you for the invitation to give a keynote talk. Let's see, what to say about the keynote talk. Hopefully people had a chance to look at it. It's mercifully short. Watch it pretty. It's a little bit abstract in the sense that I think happens as you get older. You stand back and sort of look at what's happening, and I've been thinking about the notion of when I started working on content-oriented networking, moving from circuits to packets to content, and then I started thinking about flows, and with SDN, thinking a lot about managing systems as a whole. And so, I don't know, when I look back at the arc of 50 years of networking and 100 years of telecommunications, it was just sort of something that I saw in sort of the evolution of the field and what people are working on. So I thought it might make for an interesting talk. So I hope people found it interesting.
Yeah, it was very interesting. In fact, before I ask you a question, let me just ask people to please mute their mics so that we don't have echo. And let me ask people to put up their hand by writing a message on the chat in order to ask questions. I'll take the privilege of being the first to ask. I looked at your video. By the way, very professional, very nice. Nobody believes it's the first video you recorded because it was really showing some experience. But the point is, you say at some point the protocols are bound to become a quaint aspect and everything is going to be software. But what is the difference there? Come on. Protocols are just algorithms that are engineered to make your network work. If you don't like the layering, you need to bring those algorithms within your applications. But it doesn't make so much of a difference. Am I wrong?
You're wrong in several respects. You're a friend, right? First of all, that's not my statement. That was a statement that came from Nick McEwen. And
I know it.
When I first heard it, I was in English we would say flabbergasted, meaning you're surprised, you're shocked. And as I started, and it's also not correct, right? But there's a very important element of truth in that, I think. And so I put it in there because it's provocative and I think it's pretty interesting. And you just asked the question, Marco, well, what's the difference? And I think there is a big difference. And let's take routing as an example, right? So if you have a Bellman Ford, some kind of distance vector where you're doing a distributed computation, that's what that protocol is, right? And if you're doing a Dijkstra's shortest path, you're exchanging link state information. And you're doing the computation. That's what the protocol is. If you're doing that all in SDN, and you're distributing the results out so they're reflected in the forwarding tables, but there's no routing algorithm, right? You're running some kind of algorithm of computation centrally over a graph. You're distributing results. That's not a protocol anymore, right? Similarly, you could imagine, I think this is less likely, you could imagine that flow rates or transmission rates will be monitored from the edge of the network, fed into a congestion control, logically centralized calculation, and rates would come back, right? You and I are both old enough to remember virtual route pacing in SNA, right? Back in the 70s. That's how that worked, right? It wasn't really a protocol amongst agents that were, or protocol entities that were exchanging messages. You'd talk to a server, you'd get your rate, and that's what you would be doing. And so there is a difference between, I think, protocols and a logically centralized calculation. So you might ask yourself, what is it that has to stay in protocols, and what can't be part of software-defined networking? And I think talks about, especially at the end of the day.
Okay. That means that we are back to centralized control, which is where we started from telephone networks and these kind of things. But it's just a centralized algorithm rather than a distributed algorithm. Then if you define a protocol as a distributed algorithm, that's fine. That depends very much on your definition. But I don't want to monopolize this. We have already 3 people, 4 actually, listed for questions. So let's go in order. Edmundo, you're first.
Could I ask that people turn on their video? Oh, great, I see it.
Hello. In fact, my question was following up what Marco is just saying last. So although I am younger than you guys,
not much. Not much. We had this discussion many times. Not much.
From Marco would remember Kleinrock's picture in his office with central control, which is a total mess when you go to total centralized control. So we had to distributed control. Now we return it with SDN, probably with the central control, but there you have problems also. The information, the delay of getting the information, you have a past, not recent information. With distributed control, of course, your vision is limited, but you have the overall picture, as you said in your presentation, but you have also other problems. So why do you think we are returning to that picture with centralized control? So we went from there to this down back to center. What breakthrough happened that now it's better to the picture changed?
Yeah, so that's a really good question. I also think it's a really good observation about delays of information and age of. So Tony's going to talk about age of information, right? I think that is one of the real drawbacks. So I'll tell you a story. Back in 2004, I think it was, when Jennifer Rexford was working on RCP, the routing control platform, which I think of as sort of a precursor to software-defined networking. I asked her that question, right? I called her up. I said, "This is crazy, that SNA had this vision of centralized control." Sort of back in the 70s, we moved away from that. Why are we moving back? I'll tell you her answer. My answer is a little bit different, but what she said was that, well, centralized control didn't work back in the 70s and the 80s because mostly of reliability problems, and that now there's enough understanding in distributed systems about how to scale resources and how to, do failovers and whatnot, that a logically centralized control has a really good chance of working, will work well, right? And that didn't used to be the case. So she made it on the basis of a reliability point of view. And I think I wanted to make it a little bit more from a network management point of view, right? And so people always say that, 70% of the network cost is in management. It's not in the equipment, right? And that if you have a logically centralized view, you are able to manage the network better, right? You can use more abstract tools. So if you look at how, my understanding about how people are starting to manage networks and how to configure networks using Yang and netconf, you have an abstract data model that then gets sort of mapped down to the individual pieces, but that you don't have, and you won't have, individual network operators sort of typing in CLI to a Cisco router to configure, so many buffers here and this line speed here and that kind of stuff. But this will all be automated. It will be done with verification over a set of configuration parameters. So I think what it buys you is it buys you manageability. What you lose, as you said, you lose the timeliness of information because decisions are being made a little bit further away from you. You're on mute.
Jim. Thank you. Thanks, Jim. There are several other questions, but in coffee break, we continue talking.
The next question in line is Gustavo Santos. Please activate your mic and camera, and then you can ask the question directly to Jim.
Hi, can you hear me?
Yeah, I can hear you.
Hello. So my question is related to how can we combine SDN and artificial intelligence? Because since SDN have a great view about the whole network, how can you use this information to leverage on artificial intelligence algorithms to automate some operations in network management?
Right. Okay. So that's a great question. Sort of bringing together also two pretty hot areas. I don't really know how to. Well, I don't think I have a. I know I don't have a good answer for you yet. Right. One thing I will say is that AI in and of itself is not an answer to everything, as much as some people might think that, right? But what I think you can think of is, well, what is, for instance, machine learning? What, from a network management point of view, how can machine learning help you with predictions in particular, right? And so if you're able to correlate that you're now seeing certain things happening around the network, and maybe that is a precursor to an attack, or, an example that I always heard people telling me about was that before equipment fails, you'll see sporadic failures in equipment, right? And so you'll see patterns. There are patterns that indicate, failures before they happen, attacks before they happen. If you've got all of that data centralized, I think that does give you the opportunity to do learning, or statistical learning over patterns that might help you anticipate what's going to happen in the future. But I think it's very much on a very domain specific. It's in the issue of routing, it's in cybersecurity, it's in equipment failure. So I think, it's got to be a pretty specialized problem where you're training in order to be able to do prediction.
Okay, thank you.
Yeah, good question.
Then it's turn of Sergio Palazzo. Sergio, can you come up with mic and camera?
Yes. Hi, Jim. Nice to meet you through the GoTo meeting. Thanks so much for your very nice presentation. I listened a bit, and I found especially interesting your talk. When you discuss about the SDN approach, you mentioned the concepts addressed by Tony Tremidas about freshness of the information in the talk that we're discussing shortly later on. On the other hand, Tony talks about the value of the single individual information the receiver gets from the sender, For instance, in a sequence of packets or in a single data flow. Whereas you talk about network-wide abstractions and a system as a whole, then can you give some insight more on which specific network mechanism can make possible to scale up the fine-grained concept of information, value and freshness to the entire content sets of in the data center? I don't know, for instance, through specific macro reviews applied to flows or some logically centralized SDN algorithms or whatever else. And to be a bit more provocative, do you see this matter in a top-down approach or a bottom-up approach?
I mean, it's a great question, and I guess I want to make the case that, when you think about having old information, if you're having out-of-date information, I think I don't really, honestly, I don't have any comments about an abstract value of information and how it changes with age. I think more in terms of what happens when you have old information, right? And so if you have old information, it could be the case that the network gets in inconsistent states. For instance, you might have routing loops, for example, right? Because certain information that's been over here and things have changed hasn't propagated over here. And so I think that, you have certain periods of time where old information can get you in a lot of, can get you in trouble, right? And then the only question is that a relatively short period of time? So for example, if you have, right? We've studied routing algorithms for 50 years. There have been cases where there are routing loops. There are still routing loops in the internet, for example, right? And that's why we have the TTL field. And so, so long as they don't persist for long periods of time, those kinds of flaws are just, in my mind, completely masked away by a best effort service model, right? And so you don't really require that sort of super high fidelity control in a network that has best effort service, so long as it doesn't last for too long a period of time, just because we've got all the flexibility built into the applications or the application infrastructure at the edge of the network. I think that's maybe one other point I wanted to make that I've sort of realized, actually working on the 8th edition of my book and sort of thinking about, the big picture of evolution of services, is that I used to be a huge fan of doing QoS inside the network and having routers be very careful in terms of how they were doing end-to-end routing in order to meet quality of service requirements. I think that's gone away, and that's been replaced by having a lot of infrastructure around the edges. So think about how a CDN works, or think about how Google works, or YouTube, or Netflix, or something like that, where you compensate for a network that has flaws, right? That there's old information, and so sometimes it doesn't work completely right, that there's congestion that you can't recover from quickly enough, and you get mapped onto another application level server at the edge, somewhere at the edge of the network. So I think I always say this to my students when I teach, and honestly, I don't think any of them get it, because it sounds, I think maybe you just got to think about it a long time to get it, but having a service model that allows you to have mistakes and then build up recovery at the edge, or replicated infrastructure at the edge, it's just a very powerful way to provide services, and it frees you up from a lot of worries about flaws like routing loops or things like that persist for short periods of time. So Sergio, I don't know if that answered your question, and I might ask Tony to help answer your question about a theoretical notion of the value of information and what the behavior of that might be.
Thank you.
So the next in line on the chat is Daniel Menashe. Can you please come up with mic and camera?
Hi, yes. Hi, Jim. Hi, Marco. Yes.
How are you?
Yeah, fine. Thanks. Yeah, and you, yeah, good to hear your talk. And yeah, I also wrote a question. So it's a follow up to Marco's point, and also related to previous comments. So, uh, uh, so my question is, if you have a logically centralized controller, the communication cost between the nodes and the controller may still be uh, prohibitive, even if it's distributed. Still, there may be costs that are larger than the cost between neighbors, right? So I was wondering if we can envision a hybrid architecture where nodes still communicate with each other through protocols, albeit simpler ones, to cope with these aging issues. And if so, how would this hybrid uh, architecture work?
So Daniel's question was a good one, and in some sense, I think that's being answered already in practice. In that, I think the multi-network is still sort of very much in the future, right? And so SDN is being applied primarily within a single administrative domain, so a relatively small network, if you will, right? I understand about the overhead. What you're saying about the overhead. With Ethernets operating at 80 gigabits per second, I'm just not sure that bandwidth, if you're trading off bandwidth, some amount of bandwidth for fidelity of control and information and logical correctness, I think that's a trade-off most people would make. Now, the question about old information and sort of what that could do in terms of making control not effective, I think that's still a really good problem, but I don't think that people worry quite so much about how much bandwidth there is, except in cases where bandwidth is constrained, right? And that might be, say, at the edge of a wireless network, for example. So I don't think your issue about the bandwidth overheads for management is maybe a primary consideration. I do think that the communication is scoped because control is just scoped within an administrative domain, right, within a network, at least so far, and probably for the foreseeable future.
Thanks.
Okay, we now have Giuseppe Bianchi.
Hello. Hi, Jim.
Hey, how are you?
Hi, fine. So, at the very nice talk, and at the end, you also started mentioning about programmable data planes, and you mentioned about in-band network telemetry with P4. And actually, that trend is particularly interesting because it opens up the possibility of programming in real-time also devices. And right. I saw also that in US there are proposals for new network architectures based on actually concepts similar to capsule in the 90s, if you remember. So active networks. I mean, that is a future way, for instance, they're proposing. So do you believe that we will go in that direction sooner or later, or not? There is having the network more active, because you saw it, the failure of 20 years ago, and I was curious to hear.
Yeah. So actually, I was funded by DARPA under their Active Networks program and found it really intellectually interesting. I will say that the kinds of control that people, we were looking at, merging NACs and doing in-cast type of applications. You can do that in the network. I don't think that's, to answer your question, I think the really important thing is to look for what is the compelling application where you get great functionality, not that you get a factor of 2 more efficiency or something like that. Because again, if you can burn bandwidth, who cares about efficiency? At least in the in backbone. And so that's one reason why I think that in-network telemetry to me is pretty interesting, right? Because it allows you to do something you can't do otherwise, right? You're able to measure within the network from point A to point B, at least within a set of, in this case, P4 programmable routers. It allows you to measure things in there that there's just no other way to get that information, right? And again, I think along the, at the end of the talk, I included this paper from Bell Labs that I conceptually like a lot because it speaks to network management, right? But it speaks to also using measurements that you can only do with that programmable data plane, right? And it sort of harkens back, remember the days of stochastic Petri nets and other forms of specification and verification, being able to formally say something about your configuration, right? And in that case, they're looking at real-time performance and being able to do QoS guarantees. So I think the reason I flagged the in-band network telemetry is because I think, Giuseppe, that it's a really great example of something that you couldn't have done before, and where programmability really gives you something special.
Okay, thank you. So if Giuseppe does not reply, we proceed. We have a question by Ananda Strait.
Okay, my question is about the system abstraction you mentioned. You mentioned that it is enabled by logically centralized SDN controllers, right? So for the majority of businesses now, for me, it seems to be costly to make an SDN-ready environment, especially for dealing with network security risks. So do you think SDN is or is going to be a viable solution for smaller networks with a constrained budget? And the follow-up question is, do you think there are other directions of system abstraction that might be more viable and less risky to these smaller businesses?
Oh yeah. So that's a great question, and to me, then it gets to the whole question of how you manage your network, and so I guess the reading I've been doing, or my reading of the reading I've been doing, is that there's sort of a new generation of network management that started, that's becoming popular now. So it's in the 8th edition of our textbook, but that moving away from just SNMP, right now the way, my understanding and what I've seen in practice is that it's a combination of SNMP and monitoring tools and people using CLI and scripts to configure routers and respond to problems and things like that. And that the newer approach, which conceptually is independent of SDN, is to try to abstract out a data model for what's happening, what the configuration of your network is, and then impose that configuration on the network elements, right? And after proving correctness properties about it, and it allows you to do things like lock state at n different places in the network and put in new state and do that atomically with rollback, for example. And so I think this sort of new generation of network management tools built around the Yang data model and the NetConf network management protocol that and configuration protocol, that this is sort of the new generation of what network management is going to look like, and it's a little bit independent of SDN, so you don't need to do SDN to do that, but I think that SDN sort of fits that very nicely, right? Because you've got sort of a logically centralized data model. It's a great question about SDN penetration, right? So is it going to take over the world? And there are places like Google's backbone network, like data centers, where it's been used a lot, but there's a lot of investment in equipment that and a lot of investment in people expertise that isn't quite SDN ready, I guess, maybe one way to say it. And I understand that with production networks, you can't just sort of wave a magic wand and change everything because it's a running system, right? It's like trying to change an airplane engine while the airplane is flying. That this needs to be done slowly. So I think, though, that as the benefits of being able to manage a network better because you have good abstractions for it, and you're able to work with configurations that don't require sort of individual human intervention, where you can verify properties about what you want to do in advance before you impose a configuration. That I think that as those advantages become more widespread, as it becomes more natural to sort of think that way, that SDN will sort of continue to sort of percolate out of individual corporate networks and out of the data centers into more wide area networks. I guess that's how I imagine evolution happening. It's been happening slower than I would have imagined 5 years ago.
Thank you.
So we have now Antonio Abelem.
Okay. Hi, Jim. Hi, everyone. Nice to meet you, everyone. Well, my question is about teaching aspect of networking. I adopt the top-down approach, but sometimes I identify that the students need to understand better the physical and link layer aspects to better understand how the upper layers works well. So my question is, don't you think that an hybrid approach could be better than a top-down?
It would be impolitic of me to advocate for a bottom-up approach. But I know plenty of people who are really smart and great teachers, and I think maybe, well, I'll say that in a second. So I know people who teach bottom-up. I know people who teach bottom-up out of our book. I know people who start in the middle and then teach their way out, going both down and up. So they start with, so Vern Paxson at Berkeley, you know, he starts with the network layer, and then he moves down, and then he moves up, and then he moves down further, and then he moves up. You know, I think there are people on this call who could talk about this better than me. You know, you sort of have to draw a line about where it is you're going to stop teaching in the layered architecture, right? And so I get some grief sometimes from my students that I just don't teach much at the physical layer, right? I say, oh yeah, there are really good courses in our electrical and computer engineering department. If you're interested in that, it's a great thing to know about. But if at the same time you want to teach, I don't know, you know, network management and data models and Yang and NetConf, and you want to do security, and you want to do, you know, distributed application level infrastructure, and you want to do everything between, and you want to teach down at the bit level, that's just so much to teach in one semester. So, you know, I think it makes a difference whether you're teaching in an electrical engineering department or a computer science department. You know, I'll tell you that this notion of teaching top down, I didn't invent that, right? For me, I learned that from operating systems, right? Because when I learned operating systems way back in the day, even when Mundo was young, you know, everything, it was bottom up, right? You learn sort of the lowest layers of process synchron, you know, low level stuff, memory management and scheduling, and then you built your way up. And in the 1980s, the people who taught operating systems sort of inverted that and said, oh, well, you know, let's start from the higher level abstraction and virtualization and work our way down. And for me, it maybe just means I'm more of a computer scientist than an electrical engineer, thinking that way in terms of abstracting away the lower layers just in terms of what they do functionally, and then thinking about that infrastructure and then building down is I don't know, maybe it's a computer science way to think instead of, and EEs tend to think a little bit more bottom up. And people can teach it both ways, and some people probably learn better bottom up than top down, and vice versa. So there's no right way. Yeah.
Thank you. Yeah, I agree with you. One semester is we need at least 2 semesters to detail all the aspects. Thank you.
You know, everybody who teaches in any discipline always says, oh, I don't have enough time to teach all the really important stuff in my discipline. So we are forced to sort of narrow down and say, what is it that we want everybody to know? You know, in my department, the computer networks course, it's not a required course, right? And so, but there are concepts in networking, and there are concepts in operating systems and databases that I think every computer scientist should know. Absolutely, right? And so the question is, if I told you had to teach networking and you had a third of a semester, what are the concepts that you are just so central that you'd want to get across. Something to think about.
Very good, thank you.
Marco, Renato, any comment or question on your side?
Actually, yes, I have a philosophical question for you, Jim. So you've been advocating in this keynote software-defined decentralization, okay? Which I perfectly understand from a technical and efficiency point of view, but I understand far less from political. So centralizing it, political point of view. Okay. So if you centralize everything, even if you don't want, what we have seen around is that the winner takes it all. So you end up with a single huge controller of the entire internet. Is this, do you think this might happen? Because maybe it's simply a weird fantasy of not so young Italian boys? Or
No, I think the answer to that's pretty clear, right? That to me, the question came up earlier about, well, if you're going to logically centralize things, does that mean, the question you just posed, does it mean there's just one controller for the internet? Something that the internet has been true, I think, for a long time is that it's a collection of autonomous systems, right? And they're loosely glued together right now through BGP. And so that this notion that you'll have an all-encompassing internet that's just a single point of control never happened. Never say never, but I honestly don't think it will happen. Now, I mean, there are cases, of course, with with countries where if ISPs want to operate in that country, you have to do, certain sites can't be visited, or certain firewalls have to be respected and things like that. That's not so much an issue of architecture. I think that, again, this notion of administrative autonomy means that there won't be a logically centralized control view of the internet as a whole sort of ever, right? There might be AS graphs and things like that that one can reason about. But I think that, individual networks will always be under the control of the network operator, and that they're not going to expose information outside. They're not going to expose much information outside of it.
Thank you. So, this basically boils down to say that you centralize, but not too much, which I appreciate.
Right, and I think that's sort of the way. If when you think about intra-domain versus inter-domain routing, right? I mean, that's the way things have worked now for since at least the early '90s, right? That you get a lot of administrative autonomy. That BGP is based on preferences, not efficiency, right? It's really based on strategic information about who your customers are and serving your customers. It's not based on shortest paths to, well, there is an opportunity to do that, but it's a lot more about business relationships than it is efficiency. And there's a lot of information that's sort of purposefully hidden in BGP because ISPs compete with each other.
Okay, Franco, you want to ask something? Otherwise, we don't have questions from the audience.
Always happy to chat, particularly about the way to teach networking classes. I think there's so many ways to do that. When I started my classical computer networks class for computer science students, very important, right? Not for EE students. Then what I did first is simply in the first lecture, I simply asked everybody, well, just imagine you want to transmit something from A to B. What do you need? And then over time, students come up with the concept of, well, we need a communication channel, possibly that needs to go via multiple routers, possibly in order to find paths, we need addressing, possibly in order to encode some bits, we need also a physical layer in the end. And so what students typically, just from their gut feeling, are doing is starting indeed in the middle of the networking step. Not bottom up, not top down, but just thinking of nodes, right? And some nodes turn into routers and so on and so forth. So you mentioned that there is some of us who start in the middle of the protocol stack, and I don't do that. In my computer science networking class, I start top down. But whenever I ask my students, typically second-year students in the bachelor, they, from their gut feeling, they start in the middle. So all the years, I sort of, maybe we can learn something from that. So if they, from their feelings, start in the middle, so maybe it's not the best, maybe it's a good idea actually doing so. But again, this is, I'm chatting, right? It's not really a question I have. Again, so I don't know whether our top-down, bottom-up, and this fight between the both is really manageable. I don't think it makes sense. I really sort of also starting in the middle, but to me that is counterintuitive. I'm too long in the field already. Maybe I think, I don't know.
I thought the notion of a browser connecting to a server is the most natural thing for students to think about, right? And then it just opens up all the questions about, reliability, for example, in particular. And then you can sort of get down into the network structure and things like that. So I don't know, that sort of idea was what really pushed me to start. I mean, I used to teach I taught bottom up for the first 10 years, and then I thought, I'm going to try top down. It seemed to work better. Maybe if I could just take a second, since we're talking about teaching, to advertise for a SIGCOMM education workshop that I talked about at the very end of the talk there. And it's about teaching online and teaching in the time of COVID and actually beyond that, and sort of both what resources we have to share, because I think why publishing is changing so quickly now, right? I mean, publishers are they already look way different than they did 5 years ago, and it's going to change even more. And so, how we develop community resources, how we're going to now teach our students if Politecnico di Torino's virtual for a whole year. I mean, you teach differently virtually. If you have resources, what can you do to help build a class online when your students, and a sense of community among your students online, when all your students are spread out all around the globe potentially, or all around the country. So that's what this workshop is supposed to be about, just a community sharing of information and resources and approaches and things like that. So
just teaching the class is not so bad. There also come practical courses for students, and this is the challenge in the online life.
You can have a long conversation, not now, about automatic grading.
Thank you.
Okay, we have one more request for a question by Michele Segata. Since our time is almost up, probably Michele's will be the last one, but before Michele asks his question, I want to ask you one, Jim, that so you have some time to think about. You said before, we all have to imagine what to teach, because we could teach forever the tiny details of whatever. So after you reply to Michele, I would like you to tell all of us, if you had to choose 3 things to teach to students in a networking course, what would they be?
Okay.
So Michele, go ahead. Jim has.
Hi Jim, nice to meet you. I think it's a small question. I don't know, I let you judge, but in your talk, you have basically been talking of all the abstractions we have seen through the lifespan of networks. Can you already imagine what could be the next one?
Oh, wow. I think this notion of well, it's where we are now. What comes next? I think it was either Falco or Renato. I was going to talk about, well, maybe students sort of think about, business. I don't want to say business models, right? But rather than thinking about bits flowing, you think about the companies that sort of create networks for you, and sort of taking it more from a organizational standpoint. I think that SDN is still a very systems, network management, very technically oriented way to think about things. Maybe starting to think about things about how things interconnect, because that's something that hasn't changed in a long time. Right? BGP's been around, BGP4 has been around now for 20-something years, and that hasn't fundamentally changed. And yet, I guess what I see happening is I see and you see this in measurements, right? That the network is flattening, right? In that you get companies like Google and Netflix that are attaching close to the edges, right? And so basically it becomes a backbone of private networks that want to get close to the customers and want to push their services out to the edge, and they connect then through the edge network to the customers, whether that's a cable network or a phone network or a wireless network, right? That what used to be tier 1, tier 2, tier 3 networks, I think, may be replaced longer term by more application-oriented infrastructure, like what Google's doing, and Facebook, and what Netflix are doing. And so you've got edge, and you've got service providers. And being an ISP, if you don't have services and you're just a bit pipe, may not be a good place. I mean, people have been saying that for decades, right? Not a good place to be without services. But I wonder whether there's even a business anymore for being a bit pipe, sort of longer term, if you let the trends play out to their logical conclusion. So maybe it has something to do with how networks interconnect to each other, how they share information with each other in order to get services to the customer. Because in the end, right, it's all driven by services.
Thank you.
That's pretty far out. We're not there with SDN. Okay, so Marco, I'll answer your question. So actually, to answer your question, you have to say, well, who is it that you're teaching to? So, like many of you, my comment about what you teach, that meant in an introductory network course where you've got students in one class for one semester. You want to teach them all about networking. What do you teach, right? If you have somebody only for a third of a semester, they're a different kind of student, right? And those might be students who, they may be computer science students who just want system principles, whether they be operating systems, databases, or networks. Or you may get students who are more interested in sort of policy and business use and things like that, but you want to teach them technical things at the same time. And I've taught that latter group of students before, where we talked about net neutrality, we talked about the Great Firewall of China, and we talked about privacy. But I also taught them about how the internet and how mobile networks actually work, right? So I had to figure out what are the 3 things that I want to teach them. So I wanted to teach them about reliable data transfer, which I think is absolutely fundamental, right? And teach them about protocols for doing that. So we sort of basically do reliable data transfer. I wanted to teach them about routing algorithms because, at least at the time, I still think they're important. And what was the third thing that I probably taught them? Those are always 2 things that I just absolutely love to talk about. We talked about web services and how web services are implemented, how then ads are layered on top of that, and ad auctions and stuff like that. But I got to teach them HTTP, and then we even used Wireshark, and they looked at some HTTP packets going back and forth, and you see all these ads. Well, how do those ads come in? And then you can say, well, there's this whole auction that goes on, in milliseconds. There's thousands of people, thousands of entities that are bidding, give you that image that shows up there. So maybe those are the 3 things.
Okay, very interesting. I would have chosen the same first 2, not the third one. But
what would you have chosen third?
I don't know. That's not probably something in the lower layers, because the difference is that I'm from EE and telecom, and so I would have considered something fundamental to explain to them how do you actually transfer bits or symbols, which
I do actually teach a little 4G, and just because I think they're just very.
Okay, wonderful. So I think we have to close here because the chairs of the next sessions are already complaining. Right, Jim? Edmundo and Jim are chairing the next session, but